Hello, guys. Today we are going to discuss about linked list. Linked list is a fundamental data structure in computer science used for storing and organizing data. Linked list is a collection of nodes where each node contains a data element and a reference or pointer to the next node in the sequence. This is all about linked list. Now coming to the operations of linked list, which includes first insertion at front, insertion at rear, second deletion at front, deletion at rear. Normally deletion in linked list is done at front and insertion is done through rear. That's it for now. And now we are moving on to operations in detail. Coming to the insertion in linked list. First, we are going to implement the insertion at front in a linked list by creating a node and assigning the data as 5 and address pointer as null and making it as a new node with address 1000. We set the node to be inserted at the front of the list. Now, we consider an existing list with data 6 and an address pointer is null. Since it is the last node, it has no address to point to. And assigning the node's address as 3000. And now, in the same linked list, consider another node with data 7 and address pointing to the next node with address 3000. And assigning the node's address as 2000. Making that node as head as it is the first node of the list. Now, the insertion takes place. Insert the new node to the front of the list and make the new node as the current head. And now this is how it looks like after updating the list by inserting the new node to the front of the list. And we update the value of head as 1000 since it is the address of the new node. The algorithm for this operation is mentioned above. The next operation is insertion at rear. Same as last operation, we would create a new node, which is to be inserted at rear. Now we consider a list with data 7 and address 2000 having a pointer address as 3000 pointing to next node. And the next node contains the data of 6 and address 3000 having pointer address as null as it is the last node in the list. We set the first node as head. We assign head to the variable temp and traverse until the address of temp is null, which satisfies the algorithm. Since the condition is satisfied, the insertion at rear takes place. And the pointer address of second node changes to the address of the new node that is 1000. And now this is how it looks like after updating the list by inserting the new node to the rear of the linked. The algorithm for the operation is displayed above. Now moving on to the next operation, which is deletion at front. Consider an existing linked list having 3 nodes with data 76 and 5 with the last node pointing to null. Now we assign the value of head into temp. We make the next node as head and delete the first node. So this is how the linked list looks like after deleting a node from the front. Now coming to the deletion at rear, we consider an existing list with 3 nodes with data 7 and 6 and 5 with the last node pointed to null. The algorithm is displayed here. We assign the head into variable temp and traverse temp. And since the condition is satisfied, we store temp in variable pref. And repeat the same step until the condition is false. Now that the condition is false, we delete the last node and update the pointer address of the previous node as null. This is how the linked list looks like after the deletion of the node from the end. The application of the linked list is for the addition of the polynomials. here the coefficient and the exponent is stored as the data. Here's an example of the addition of two polynomial using the linked list, and thus the result is obtained.
Ta-da!